Here, this is a cooling tower, as we see here. Okay, this is here the base of the cooling tower, and after this vibration absorber. Okay, to here, to here, to here, to 6 vibration isolator. Every set is 3 pieces. This is the drain pipe. Okay, connected here. This is the drain. This is the start, and here this is the high flow. After this butterfly valve control to open and close the drain. As we see here, this is open. Okay, it's 3x4 open, half open, and 1x4 open, and this is closed, and this is here. This means it is totally open. Sorry, it's here, so it is totally closed. This is the indicator. Because it's working, it cannot make drain. Here, this is the water supply and the float valve. As you see here, the cold water, the water come here because there is heat exchange between the air and the water, the hot air from inside and water. This fills inside. This is the water that come inside it, and as we see here down, I don't know if we see or not, the water is, let's make it focus, yeah, here, as you see here, the water is coming from the fell, from the top. Okay, we remove this for maintenance, but must be covered like here. This is the ladder to going up, and we'll go up to check. Here, this is the cooling tower. This is Marley Trade Park. As we see here, the fan. Okay, so if we open this side here, we will see the same. Okay, this is the fan with motor. Okay, and this is the fills, as you see here, this side. Okay, so this we have 2 parts, one right, one left. It is the same. We will go up and see all the details. Let's go up and check here. This is the fan. We are inside the room. This is the water here, and this is the fan. Okay, and as we see, this is the motor, our motor, and this is our fan. And this one must be closed. Okay, so we will fix this one side. We will lift it up and we close it. Okay, let's go to the top and see also the other details. Here we are in the top of the cooling tower. We went up. This is the water pipe, and this is the fan. As we see, this is the fans that we see from the bottom. Okay, let's go this side. If we open this here, okay, we will find as we see here, the water is coming inside nozzles. Okay, you cannot see now because the water is going through inside it. So let's close it. This is simply the cooling. This is simply the cooling tower. Here. working. Okay, this is here the top roof. So this is simply the cooling tower. Okay. We will continue here this pipe connection because in the last part we checked the components of the cooling tower and the sprinklers here. Okay, we are here in the piping part. For the piping part, this is the supply pipe here for the cooling tower. This one is coming from the condenser. Okay, it is hot water, little bit hot. Okay, and it entered here and the sprinklers. After this is going to the fill that we shake together, the plastic fills, and going down with cooling. Okay, so this is the pipe that is coming from the condenser. Okay, as we see here, we have two butterfly valves. One butterfly, this is the main pipe. This is the main pipe. Let's give one branch here to this part, left part, and give one branch here to the right part of the cooling tower. In the case of the cooling tower working, these two valves, butterfly valve, must be open. As I see here, it is open because it is the same line with the pipe. If it's perpendicular to this pipe, this means it's not working, it's closed. But in this case, it is the same, like parallel with the pipe, so I can understand it is working. So this is the pipe that it is coming from the condenser, and after this it give here the nozzles and the sprinklers, and after this it gives the fill. So this is the idea, and this fan motor is used. This fan is used to remove the heat from the water. Let's go down and see the other pipe, because this is pipe is coming from the condenser entering the cooling tower. Let's see the pipe that is going from the cooling tower, the chilled water that is going from cooling tower. But we must go down, so let's pause the video and go down to check it down. Before we are going down, this is the water is coming here. As you see, this is the fills and the nozzle here in the top. Okay, and this is the water is coming as we see here. Okay, this, as we told before, it is the drain. Okay, we have lower pipe. This one is closed, must be closed. This perpendicular, as we see here, this means it's closed. This butterfly is closed because we cannot use drain in the same time that we are using the supply pipe. As we see here, this copper pipe is supplying the water here with float valve, and also we have drain here at the end. Here, I'll show to you when I go down. And this upper pipe is for overflow. Also, in the case that the float valve is not working, this one will work. Let's go down and check the other pipe connection. Here, this is the pipes that it is go out of the cooling tower and go to the condenser. Let's see Exactly, there is one drain here, as you see. It must be closed. And this is the two valves that we checked from the top. If you remember that I said this in the top pipe, it's open, and here down it must be opened also. So this is the pipe that it is going to the cooling tower. That's going from cooling tower. Okay, as we see, let's check. This is the right part of the cooling tower. As we see here, this is the right part of the cooling tower, and this is the water supply. As we see here, this is the main pipe for the water supply, so this valve must be open. Okay, this valve is coming here, and this drain is closed, and after this it is going here to supply the water to the system, and here also the drain. So when I'll go to the office, I'll draw the cooling tower and we can together study together, and I'll show to you. This is the other side, the drain. Okay, let's go inside and see this pipe. This pipe that's coming from the Schiller, and this is like the return, and this is the supply to the condenser of the Schiller. Let's go here. Also, this pipe, it's also have drain, as we see here. This is the drain pipe, it's going here. Okay, let's go inside. And here is this is the control panels. Okay, this is another control panels here for the cooling tower. I'll show to you inside. Here, this is the control panel, 484 volt here in the United States. As we see here, it is in auto mode. This is the right part of the cooling tower, R, the right part of the cooling tower, and L here we rotate this left part of the cooling tower. Okay, this is the cooling, this is the tower. Okay, cooling tower. As we see, this one is on. Okay, so this is working in auto mode. Okay, in case of leakage or anything, we must close the system and make it off until we make maintenance and return back, or if we need to make it hand, it's okay. Now let's go inside. So we are taking step by step the system. As we see here, let's start with the supply pipe from the cooling tower. As we see here, we'll follow this line. Okay, another time we will explain the sensors and everything, but now we are explaining the pipe. As we see here, condenser water supply. This is coming from the Schiller, from the cooling tower. It's coming from the cooling tower, it's going here. Okay, this is strainer, and here we can drain the water. This one must be closed. Okay, and this one must be open. Let's go here. This one is going here. As we see the arrows, it's going here to the condenser pump. As we see here, this is the condenser pump number 1. As we see here, the pressure is about 18 psi. This is coming here to the pump, the condenser pump, and after this it's going here, the condenser water supply is going here. As we see, we are following the line. Here the condenser water supply will go here. Okay, this Schiller is not working, so if we are following this line, if you remember, so not to be confused, this line. Okay, this line, and we will go here. It gives Schiller number 1, but Schiller number is out of service, so this valve
this valve must be closed here. Okay, as we see here, this valve is closed. If it's like this, the same line like this, it will be open. But this is closed, and we put, look here, so nobody can open it. And after this, we are following here. As you see, condenser water supply. As you see here, there is valve here in the top. It's open valve, and it's going to our chiller. This is going to chiller number 2. As we see here, condenser water supply. It's going here. This valve is open also. The pressure is about like 17. It was 18 here. Here it is 17. This valve is open also to indicate the pressure. Okay, in case that I want to change this pressure gauge, I lock this valve, this gate valve, and I change it. But now it's open, so can indicate the pressure. It's going down here, also here with this open here with this strainer, but this is closed and plugged. So if anybody open by mistake, this will not drain anything. After this one, there is flexible connection here. Okay, this flexible connection, and here is our pressure. After this is go to the condenser. Okay, this is going to the chiller condenser. As we see, this is our chiller condenser. Okay, let's follow back. Okay, here this temperature is 80. Okay, let's follow back the condenser water. It is going outside from the of the chiller. As we see here, the temperature is 80 Fahrenheit. It's going inside the condenser. After this, it will become hot. As we see here, it is like 87 Fahrenheit. So it is coming like 80 from the cooling tower. It is going like 87, and after this it will be the same. It will be go here for like flexible joint. After this it will go here again. As we see here, condenser water return. We will follow this water return. As we see here, we are going back in reverse. If we are going here, it must give here this chiller number 1, but it's closed here. Okay, and it's locked. Let's go out here. It's here. It is the same temperature as we see here, but I don't know if you can see from here, but it is like 87. It is the same. And after this, it will continue. Okay, there is bypass here between both. Okay, and it's going here, continue here. Let's go to the cooling tower. Okay, let's continue here. This upper pipe, as we see here, this pipe is continue. It's the upper pipe. It's giving the cooling tower. Okay, so this is our cooling tower pipe connection from and to the condenser of the chiller. Okay.
Now we explained everything on the roof for the connecting between the cooling tower and the chiller. Let's see the situation here on the PMS. As we see here, this is the chilled water system. This is the chilled water system I have here. Let's go more clear here. I have here the chiller one that we told that it was not working, and we locked this chiller, and the working one is chiller number 2. So let's follow it from the cooling tower. As we see here, this is the supply from the cooling tower. This is the lower pipe, if you remember, or you can come back to the video and check for the cooling water supply, the CWS cooling water supply. As we see here, cooling water supply temperature is 79.8 Fahrenheit. This 79.8. As we see here, this one is TS, temperature sensor. Okay, as we go here, we will go direct here. This is the water supply. This is the water supply. So it's coming from the cooling tower. It is going to the condenser water pump number 1. As we see, that's the working one. It is going like here, the condenser water pump, and it is give here to chiller number 1, and after this it will go to chiller number 2 to the condenser. After it is finishing here from the condenser, it is going back. This arrow is wrong. This arrow is going like this here. It is going back. This one is closed. This is going back here in this line. Okay, this is the line. It is going here. This one is open, not closed. This one is here, and this is closed for the chiller 1, but it's going continue. Okay, this one, sorry, we are here in this line. Okay, this line is for chiller 2. It is going this side. This is coming also from chiller 1, but this arrow is here, so it's going from here. This one is closed here, so it's coming from the chilled water, the condenser water return. It is going here to the condenser water return. It's return here. Okay, and this is the bypass. This is the bypass line, if you remember. Okay, and it is going back to condenser water return. It is going like 84.5, so it is entering like 79.7, and it is going like 84.5. This means it is about 5 Fahrenheit degree, as we sit in the chiller. Okay, so this is here in the PMS system. It's showing for the condenser water details. Okay, as we see here, also here it's showing like points. It's condenser water pump, the status STS. It is running. Okay, it is running started running at 6:04 a.m. Okay, this is starting running. Okay, and it is on. And for this pump, standby pump 2, it is stopped. Okay, it's not working. And for this shielded water pump, it is working also. This is a shielded water pump. This is another case, but now we are concentrated in condenser water pump and condenser water pipes. Okay, so as we see here, this is the connection between the cooling tower and between the chiller condenser. Okay, this is the first circuit in our building, and later we will explain the other circuits one by one and in simple way, and will not only explain here, it's also we will, as you see, we explain inside and see it's like in practical. So if you are a professional engineer, or if you are like engineer just starting, you can understand easily all the system, because the system is easy if we are following it step by step. I think some people, they are trying to make it more complicated, but it is easy system, and if we are followed one by one and drawing and in real, it will be more easy, as I done in this video. Okay, I hope you got some information in this video. And also, to close this issue, I will draw to you here all the system again. Here, as I promised, let's see the drawing, and according to it we will see also what is in real. Okay,
we will start with the cooling tower. As we checked, this is the cooling tower. Okay, let's see at first. Okay, the drain. The drain is connected here. This is 3-inch drain, and this is gate valve, and this is overflow 3-inch. This means this is the drain for this area, and this is the overflow 3 inches, and there is gate valve. This is butterfly valve here, and go to spill over the roof drain, as we see here, 3-inch. Let's see this one here in real. Again, we are revising. Okay. This is the 3-inch drain, and this is the valve between the overflow 3-inch also and the drain for the bottom and overflow for the highest point. We are going down. It's here connected to the other side. Let's go to the other side. The other side here is the same. This is the drain 3-inch, and this is for over drain. This one, it's going here, and in between there is butterfly valve, and it's coming here and going down into the floor drain. And this is the other side, is coming here, not connected together, and it's coming here for the floor drain. This is the first part. Okay, let's go back to the drawing to check the other detail. We have here back. So the drain and overflow, we finish this part. Okay, and this is our cooling tower. Let's see here, so we finish this line. Let's go to this line, this 2-inch cold water makeup by plumber. This means the plumber will supply this one, as we see here, gate valve, and here this is the meter and another gate valve, and after this it will go to the cooling tower. Let's see this one here. This is the makeup water. This is the main supply. Okay, and here is this gate valve, and here the meter, water meter. Okay, with a sensor, and it's going here. There is bypass between. And after this, let's go up. If we follow the line, let's go back. This is the line, and here we are going up. Continue here and here, and this one, and let's go here. It's going to the cooling tower. It's coming from here, the side, as we see. It's giving this side and giving this side. You know, all the valves open. It's giving this side here. Okay, it's there is one drain here. We are following the right one. There is a drain here. Okay, in this 90 degree, and this is in this 90 degree, this drain, and we are continuing here. We will meet here another 90 degrees, so it must be the drain, and this is the makeup water supply. Okay, the same, the other side. As we are going here, this side, it will be here. This is the water supply that's coming from the room. This is drain in 90 degree, and we continue. Another drain. This is closed. This is closed, and it's going up. This is the makeup water. Okay, so we finish this line as per drawing. Okay, let's check the drawing. Now we are learning how to read the drawing. Okay, this line. Okay. We'll go to this line. This line, it is coming. This line, we can take one line by one line. This is shielded water supply. Let's start with this supply line. Supply line, it's from bottom as we know, and the return from the top. So the supply line here, it's 10 inch as we see. To continue, it become here 8 inch. It is going here, and it is giving the first one. It's pump number 1, the condenser water pump. So it's giving like, let's check this part. Okay, but it is giving like 8 inch because continue 8 inch. After this gate valve, strainer, and drain valve. After this is pressure gauge, and this is going to the pump, and there is drain here. After this, it will go to the another one. There is gate valve and go to another pump, standby pump. This strainer, the same, and gauge valve, pressure valve, and the pressure gauge, and the drain, and it will go to also shielded water pump. Okay, it will continue again. Let's show this one from here, from the cooling tower. Supply line, we are talking now about the supply line. Okay, this is the supply line. It's coming from this side, here right side of the cooling tower, and here left side of the cooling tower. There is a drain here for this one, and there is a drain here for this side, and it's connected together. Okay, and the two valves is open. Let's go inside. This is the supply line. Okay, as per drawing, it's saying it's giving the condenser pump, and as per drawing also there is gate valve. After this is the strainer. The strainer have drain, and also have support here, and it's have drain here as per drawing, and the reducer to go inside this one, and also it have pressure gauge here as we see. After this, as per drawing also, this between the two pumps there is gate valve, butterfly valve, and it is the same. It's going here. This green color is for condenser water, and for blue one is for shielded water. So it is the same. It is coming here and give strainer, and this is the drain, the support, and giving here to this reducer. So the question here, why this one is not insulated and this one is insulated? Because this one is used for both. The standby pump is used for condenser water and for shielded water. It's used for both, so this is insulated. And as you see, this half green and half blue. This can be standby pump, can be for both. But this one is used for condenser water, so it's not insulated. And here we have pressure gauge. Okay. And here this is our little drain. Okay, we will continue as per drawing also. We'll continue for the shielded water. There is here butterfly valve and the same issue. Let's revise it again. This is for Schiller shielded water room. As we see here, this is the same issue. It's coming from here, and this is the strainer and the drain, and this is the gate valve that is going the same. Okay, as this is the drain here, and this is the drain in case of that we need to make maintenance or something. This is the pressure. As we see, this is the difference between the condenser water. As we see here, the pressure of it's like 18 psi, and for shielded water the pressure is like 38. Okay, this as per drawing. So for this line, let's continue the drawing. So we cover this supply line. We cover we cover this supply line, 10 inch, 8 inch, and here it's going to gate valve and the strainer and the drain and the pressure gauge, and after the strainer there is gate valve here between, and going to the another standby pump. This half shelled water and half condenser water. After this go to shielded water pump. It's okay. Let's go to the last line, and after this is going to the Schiller. Okay, let's see it before we continue. So it's finished here, the supply. Okay, and it is going to the Schiller, this condenser water supply. Okay, it's going to the Schiller. As we see here, this is the strainer and the gauge. Let's do the return, and after this we'll check in the drawing, so it will be the same or not. This is the return. It is going here. This is the return. It's gauge valve, flexible gate valve, and this the condenser water return. It's continue here, and this is bypass between, and it's go to the top of the cooling tower. Let's see if it's the same in the drawing or not. Here, this is the return, and this is the gate valve. It's this one, the return. It have this temperature gauge and pressure gauge and gate valve. It will continue here 6 inch. It will be the same for Schiller 1 and Schiller 2. It's the same, connected together, and it will become 8 inch because it will, for the Schiller number 2 it is 6 inch. After this, when we add this Schiller number 1, it will become 8 inch. It will go 8 and go to each part of the cooling tower. Okay, so I hope that we covered the drawing, we covered also inside everything. I want to mention that we faced problem in Schiller number 2, that the let's check it together. This in Schiller number 2. Okay, if we check the reports, and here for the evaporator. Okay, let's go back. We need to check the history. So the historic, as you see here, historic diagnosis. This is train. Okay, as we see here, this reset has occurred. Let's go to the top. This is the last. Now we are. Let's go. We are June 24th. Okay, 2025. This means this one was yesterday. Okay, this one is the error. It was evaporator water flow overdue, and the previous one is this is in 23. This is what I am talking about. 2:30 p.m. June 23rd, 2025. The evaporator water flow lost. The evaporator water flow is lost. This was the error in Schiller 2. Why the evaporator flow lost? Because there was leakage here in the cooling tower. In this area, there was leakage down here. Let's go down and set the area together. Here, this areas before it have leakage more than like this. It's have leakage. So we drain all the water from here. We shut down the cooling tower and shut down the chiller, and we drain all the water and we cleaned it. And also after this, let's close the power, the light. Let's go here we brought this sealant. This sealant is 2 sealants. Okay. This is quick sealant. Take like 30 minutes, and we mix it all together here. Okay. Now it's, as we see here, all. Now it is dry. We use it for stop the leakage and for solving the problem. So we covered everything about the water cooled cooling tower, this Marley trademark, and here this is our chiller, this is train, and we checked the condenser water circuit supply and return. In another video we will explain more about the shielded water and the expansion tanks, and also the other one. This is air cooled cooling tower. Okay, we will check it in another time, or if you want me to cover it is in one time, let's cover this one. For the chiller, we have here this chiller number 3. We have here this chiller is served by cooling tower, but this is not water cooled, this is air cooled. Let's go outside and check. This is our air cooled. This is another cooling tower. This air cooled cooling tower. As we see here, as we mentioned, this is a vibrator isolator, and we go here, as we see here, for the cold air cooling tower. As we see here, this is V shape. As we see here, as you see, V shape coils. This is for cooling. Okay, with not water cold like the other one. It is air cold, and the fans here in the top. This is very simple. And let's see the pipe connection also. This is the control. Okay, it is on. And let's see the pipe. Here, as we see, we have 2 insulated pipes and 2 uninsulated pipes. So we can understand this is the uninsulated 2 pipes. This bring hot water. Okay, so this brings the hot water from the condenser. Okay, this means this is the 2 the 2 pipes is the condenser water return. It's going here, as we see here. This is where we can, okay, this is where we can check, and this is here, as we see here. This is the site glass. It's going here to the system, and this is the out of the system. This for electrical cable, and this is carrying the cold, okay, water, and it's going inside, and this is a vent. Let's go inside. This is the temperature sensor that we talked before. Here, this is the temperature sensor that gives the BMS, the reading of the outdoor reading, and gives the signal to this one train type, this cooling tower train types, trademark. Let's go inside to check from inside this air cooled chiller. Let's go inside. This is our chiller that is served by air cooled. As we see here, let's go to this side. We will see here, this is the 2 pipes, okay, for the hot water, and this is, as we see here, this is pipe type L, okay, and this is the vent pipe that I showed to you, high pressure vent pipe. And this is insulated is the pipes that is carrying shielded water. This means the supply pipes. This to supply, it is going to here. After this, it's going to the condenser. This is a condenser, and the other pipe is going here for circuit. This one is going for circuit 1, and one is going for circuit 2, and it is going to the condenser. The condenser here, we have here the shielded water, the other side, as we told, and here it is going to the condenser. Okay, this is the return. Okay, this is the return, and for this one, for this air, it must have, from the condenser, it must have a vent. This is different between the cold water and the air water. The vent is going here, and it is going outside. So we explained that cooling tower, this water cooled cooling tower and air cooled cooling tower, and we explained the condenser water circuit, the supply and return inside, and how it connect to the chiller, and also we checked that drawing. So I think so that in this video we got much information about the cooling tower and condenser water circuit and how it connects to the chiller. Thanks.